Okay, hi everybody. In this video, we are going to calculate some probabilities, specifically when you're given a table worth of data, like this one here. So if you got a problem that looks like this should hopefully be the right video for you. So in this particular question, it looks like scientists are attempting to use a new method to identify gene mutations. Sounds like fun. The results are in the table below, and we have all these different results. So positive result, negative result, blah, blah, blah. And we're asked several different questions. What is the probability that the subject has a gene, real negative, all that good stuff. So we're going to take these questions one at a time. Before we start, I just want to make sure we back up and look at what the most basic example or basic formula for probability is. So here it is. The probability of an event or a thing it can always be written as a fraction, and it's the number of times that event occurs divided by the total number of outcomes. So remember this, make a note of this. This is what we're going to use to solve these problems. So let's do the first one. So here's the first question, probability question we're going to answer. What is the probability that the subject has the gene? So based on that formula, we're looking for the event is having the gene. So I'm going to grab my pen here. Let's see. Okay, so having the gene. So it looks like subject has the gene. That's this row of the table right here. There we go. It looks like there were 91 total people who had the gene. Okay, so that's event A, having the gene. And then according to the formula, we need to divide that by the total possible outcomes in the given scenario. And it looks like the grand total, if you add up all these numbers, 87 plus 4 plus 13 plus 202, looks like your grand total is 306. So what is the probability that the subject has the gene? Well, there are 91 people that have the gene out of 306 people in the study altogether. That's your probability. You can write probability as a fraction always. Sometimes you can simplify that fraction, or lots of times we turn the fraction into a decimal or percentage. I'm going to do that for these problems. Just make sure whatever your instructions are, what you follow. So I'm going to turn these all into decimals. I'm going to round them to the nearest hundredths. So if I do 91 divided by 306, I get 0.297. I'd like to round that to the nearest hundredths, which gets me 0.30. So that means approximately 30% of the people in this study had the gene. Okay, so here's the next question. What is the probability that the subject has the gene and the result is negative? Now, I do want to say we are just going to be pretty much using that basic formula. The probability of an event is the number of the times that event occurs divided by the total. There are, of course, other formulas, other ways to do that, especially when questions get more complicated and things like conditional probability come into play. But we're just, because we have a table, we're just going to use that one simple formula and just use a little bit of critical thinking to make sure we have the right numbers in the right place. And this will be our first good example of that. So what is the probability that the subjects has the gene and the result is negative? So they have to be in this row because they have to have the gene, but they have to be in this column because it has to be a negative result. And there are only 4 people that met that criteria because it has to be both. It has to be having the gene and a negative result. These 87 people here, they had a positive result, so that would not meet the criteria. So it's really only just those 4 people out of the 306 total. The only time that your total is going to change is if it's a conditional probability, if we have that word given in there somewhere. We'll come to that later. But otherwise, your total basically just stays the same. And there's the top is what changes. And in this case, our top was 4. Our numerator is 4. So 4 divided by 3 is 6. If I want to round this to, I said the hundredths, I would round this to 0.01. So 0.01. So what is the probability that a subject had the gene and the result is negative? Pretty slim. So it looks like this gene testing method ain't too bad. Okay, so here's our next one. What is the probability that the subject has the gene or the test result is negative? Okay, so the subject could have the gene, so it could be anybody in this, this row, right? Or the test result could be negative. So it could be anybody in this column. It said or. So it didn't say and. It didn't say, it has to be both things at the same time. It could be either or both. And so if we look, I've circled quite a bit here, but I want to make sure that I don't double count any people. So there were 87 people who had a positive result, and they had the gene, which is 87. There were 4 people that had the gene but had a negative result, right? And then there were 202 people that had a negative result, but it looks like they did not have the gene. So those are all of the individual numbers that I circled. Those are the people who either had the gene, had a negative result, or both. So I'm going to add those 3 numbers together, and my total is still 306. So let's add those up. There we go. 87 plus 4, and make sure that if you're doing this the way I am with this kind of calculator, you do all the addition first, get your total, and then divide, assuming that you need to convert to decimals the way we've been doing. So add first, get the answer, then you can divide. So it looks like if we want to round our probability to the nearest hundredths, we're going to get 0.96. Yeah, it's pretty high, 0.96. All right, moving on. Okay, so the next one is, what is the probability that the subject has the gene given that the result is negative? So now we're into slightly different territory here. We know for sure that the result is negative, and it looks like there were 206 people that had a negative result. So my total, that number that's going to go on the bottom, the total possible outcomes, it's different now because I have different constrictions. So the total this time, instead of the 306, looks like it's 206 because there are only 206 people that had a negative result. And I know for sure that whatever person or whatever my probability is coming from this particular pool. So now that I have that and I've narrowed down what part of the chart I'm looking at, what do they want to know? Probability that they have the gene. So this is having the gene is that first row. So it looks like there are 4 people in this group that had the gene, but they had a negative test result. So I get 4 over 206. Let's round that to the nearest hundredths, and I get 0.02, it looks like. 0.02. All right. Okay, so the next one. What is the probability that the result is negative given that the subject has the gene? So it's another conditional probability. It's given. We know for sure that the subject has the gene. So subject has the gene. That was this, we're using this row a lot apparently, but that was this row here. And it looks like there were 91 total people who had the gene. And we are only looking at those 91 people because this is a conditional probability question. So that must be our total, 91. Of those 91, or of those numbers in that row, the question was, what is the probability that the result is negative? So negative was this, this column here, and it was the 4 in this case. So I could only look in this row, and I had to determine from this row how many people have the negative result, and that was, according to this chart here, 4. So I got 4 over 91. And for the sake of consistency, whoops, let's turn this into a decimal. Probability, like I said, can always be written as a fraction, always, or you write it in decimal sometimes, or sometimes a percentage. Hopefully, your homework question, it'll specify. Just careful about rounding and reducing. Sometimes these fractions can be reduced. So this one, if we round it to the nearest hundredths, we're going to get 0.04. Okay. All right, so here's the last question we're going to look at, and it is not looking for probability. The question is, are having the gene and having a negative test result mutually exclusive? So first we got to make sure we understand what mutually exclusive means. Basically, it means the two things cannot happen at the same time. Let me think of something good. So you can't roll a single dice and have it be a 4 and a 2 at the same time. It has to be one of them. Or you can't pull a card from a deck and have it be a club and a heart. It has to be just one of those things. So those are mutually exclusive. Those are things that can't happen at the same time. Another example is you can't walk on the sun and be alive. pretty extreme, but it still works. So basically they're asking us, is it impossible to have the gene and to have a negative test result? And according to this, that's not impossible at all. It looks like there were 4 people that had the gene and they had a negative test result. So I would say no, this is not mutually exclusive because these 2 events were possible to happen at the same time. It was possible for the subject to have the gene and to have a negative test result. If there had been a 0 in that box, I might have considered saying, yeah, it's mutually exclusive, but it wasn't. It was clearly proven to us several times that this is not mutually exclusive. These events are not mutually exclusive because they both happened at the same time. So that will be it for this video. This was pretty simple because we had a table. I know there will be several times where you're asked to find different probabilities, conditional probabilities, that kind of thing, where you don't have a table. So I'm going to leave some links in the description so you can look at some more resources. And if you have any questions, please feel free to let me know. And I wish you the best of luck.